So we've already talked about the area of rectangles and the area of parallelograms, but we need to talk about the areas of the other plane figures that we've discussed, which is the trapezoid, the rhombus, the kite. Okay, so first let's look at the area of a trapezoid. So let's say we have a trapezoid here. We can see I have labeled base 1 and base 2 and my height. Now, what I've always been doing when we've been discovering the other area formulas is try to relate it to the area of a rectangle, right? And we know that the area of a rectangle is area equals base times height. So if we think about that, oh, it's not going to work, is it? Area, oh, there it goes. Area equals base times height. And when we found the area of a parallelogram, we made it look like a rectangle, and we saw that the area of a parallelogram was also base times height. And now we know why that works. It's because rectangles are also parallelograms. So it all actually flows from the area of that parallelogram. Well, let's do the same thing here. We could actually, now we've already worked with trapezoids before, and what we did with the trapezoid, is, if you remember, we actually drew in our height here, and we drew in our height here, and we made this a rectangle plus a triangle plus another triangle, right? And that's one way to do it, and that's absolutely fine. But now we could actually use an area of the trapezoid, the formula. Okay, so let's discover what that formula says, or where it comes from. So watch what I'm going to do. I'm going to take this trapezoid and I'm going to double it. So notice I'm literally just pulling this apart. Okay. Now I have two of the same trapezoid. And I'm going to rotate it just like this. I'm not changing its size. Okay. And I put it together. Now, what did I just create? What does this look like? Hopefully you're saying parallelogram, right? Yes. I just created a parallelogram from the trapezoid. Now, if I label my parts, up here this segment should be my base 1, right? Because that's just what it came from. And down here is my base 2, and it has the same height. Now think about the area formula of a parallelogram is base times height. But what we did was we actually took the area of the trapezoid and we doubled it. So keep that in mind for when we're finding the area. Now if I do base times height, okay, my entire base of this parallelogram is actually base 1 plus base 2 of my trapezoid. And then we have to times it by the height. That would be if I doubled it, right? That would be the parallelogram that I created. The trapezoid is actually only half of this parallelogram. So if I want to find the area of the trapezoid, I just have to take this formula and divide it by 2, right here. This is actually the formula on every formula sheet for the area of a trapezoid. It's the sum of the bases of the trapezoid times the height divided by 2. So you can see if we take this one out, there we have it. We have half of that parallelogram. Pretty cool, right? The next figure that we're going to look at is the kite and rhombus. The kite, so the area of the kite and rhombus are actually the same, the formula that is, and it all has to do with the fact that the diagonals are perpendicular, okay? So while I'm showing you this for the kite, note that it's the same process for the rhombus, okay? So let's say I have this kite and it's fixed inside of this rectangle. Now, if I were just to imagine the area of this rectangle, okay, the area of the rectangle would be base times height. Oops, base times height. Okay. Now, what is the base and what's the height? Well, the base would be the length of diagonal 2, as we have that subscript. So diagonal 2 is the length of this diagonal of my kite, and the height would be the length of diagonal 1, which goes from top to bottom here. So the area would be D1 times D2. Now, what you want to notice, though, is that this kite does not fill the entire rectangle. So we need to figure out, okay, then what's going to be the area of just the kite within this rectangle? Okay, so let's take a look. Let's move these colored pieces, and we've done something similar to this. I forget what I was showing, but I did something similar to this before. So I'm going to move this part here, just flip it without changing the size, right there, and it fits right nice perfectly. I'm going to flip this as well. fits in perfectly. And what I just created was another rectangle. Okay, we could see that it is half of this original rectangle. So one way we could say is, all right, well, it's d1 times d2 over 2. Yes, but now let's look at just this yellow rectangle, right? If I wanted to find the area of just this yellow rectangle, it would be still d2, which is the base, but now it's only half of d1. So now the area of the kite is half of d1, which we could just write over 2, times d2. So you could see where those formulas come from. That's the same process that we would use for the rhombus. So this formula, d1 times d2, the length of diagonal 1 times the length of diagonal 2 divided by 2, would be how we could find the area of a kite and rhombus. And here I just want to show you quickly the rhombus example. Notice we're going to do the same thing, right? So I'm going to flip this left and right. It fits nice perfectly in there. Let's do the same thing with this one. Fits nice perfectly in there. Again, thinking about that area formula for the rhombus, here we have d2 as our base, diagonal 2 as our base, and then half of diagonal 1 for the height. So leading us to the fact that the area is d1 times d2 over 2. Wonderful.